So why don't you try this question here? Prove that the following 3 points are collinear. So you get the point A minus 2, 1, B minus 1, 0, and C 7, minus 8. Now first of all we have to see that they actually have the same gradient. So you could look at the gradient of the line MAB. So that's the gradient of the line AB, and that's going to equal, well, we can call this x1, y1, x2, y2. So there's going to be y2 minus y1, so it's 0 minus 1, 0 minus 1, divided by minus 1 minus minus 2, so we've got minus 1 minus minus 2. So that's going to give us on the top line minus 1, and the bottom line, the two minuses cancel out, that would be plus, so that'll be minus 1 plus 2, which is a value of 1. So the gradient there is going to be a value of minus 1. So the gradient of the line AB is minus 1. So now we could look at the line BC. So we could say the gradient M of BC is going to equal, well, we do the same here with the B and the C. We have minus 8 minus 0 divided by 7 minus minus 1, and that's going to give us minus 8 upon 7 plus 1, which is 8, which equals minus 1. So we know that the gradient of the line AB is the same as the gradient of the line BC, but this line AB and BC have a common point of B. So it means that we've got the line here, which is going to be A and B. Now the A and the B has got the same gradient as the line B and C. So here's another line here, B and C. So they've got the same gradient, but this point B is the same as this point here, B. So they must actually lie all along the same line, which is A, B, and C. So why don't you go ahead and try this one for yourself? Prove that the following 3 points are collinear. A, the point 2, 2, B, 6, 4, and C, 10, 6. Now this is just the same as the previous example. Now whenever you've worked through and proven it, you can always take these points and put it in the graphical calculator and just check and see whether they do sit in a straight line. Now I'm not going to work through the answer here, and there's a very specific reason I'm not going to work through this. It's because at some point you're going to have confidence in your own mathematics and your own abilities. And as you work through the course, you'll get better and better at mathematics, and as you work through more examples, you'll become more confident that you're getting the right answer. So I won't always work through all of the examples. There will be some examples that I'll just leave and you have to work through and be confident that you've actually done it properly. So it's just about building up mathematical confidence in yourself. So thank you for listening. I'll get you in the next video. Goodbye.